Okay, so this is part two of our overview of relational databases, and this is the second part, and this really focus on what we call the SQL. So we look more at the commands we use that we when we're talking to a database management system, the commands we use to get data out. All right, so we talked about the idea of this, the value proposition of a database. It's knowledge. Right? We put data in, we can get knowledge out. All right, it's and we can ask questions of getting once the data is loaded, we can look at why, where, when, how, what, who. All of these things make up what we're in a we need to make a decision. These are all the things we need to weigh in making an informed decision. All right, so that's really as our objective. In particular, with this whole data to information to knowledge pyramid. It's really this question of the who, the where, the why, and getting insight on that lets us make a good decision. All right, and the database is the means by which we do that. All right. So in order to do that, we talked about the need of a relational database to have the structure and the design. It has to be designed, and um, so there's and once again, the reason for that is because the mathematical basis of it. All right, CODS rules. What CODS rules are designed for is to organize the data in such a fashion so we can apply the algorithm, basically the SQL or relational algebra algorithms to give us the correct answers. All right. So this normalization is a process we go through, and what it does is a couple things. First, it eliminates the redundancy of data between tables, and redundancy is like the best way to describe redundancy is it is the type of thing where you'll have same information or same data is maintained in multiple tables, all right, or multiple spreadsheets or multiple, and then the immediate question that comes to mind is which one's the real one? Where did that number come from? Why is that number different than that number? All right. So the idea is with a database within the database by eliminating that redundancy, what we have is if we ask a question of it, what we get back, it should be the single source of truth. If it's designed correctly, it should provide for us the single source of truth. Now, that's easy to say, but not necessarily easy to necessarily pull off. All right. Um, Other thing about normalization, it lets us organize the data efficiency, gives us the flexibility to make changes without having to, make major structure changes. One of the things that within a relational database, we said there is a structure required for us. Okay, so we have to do the design up front. However, we still have the ability to make changes. We don't unlimited, not uncontrolled changes, but changes to that design. We still maintain be able to do that, the ability to do that, and that's really what normalization lets us do. And then third thing it does, it eliminates the potential for what we call data anomalies. All right, like for example, what we call a many-to-many join table. All right, so what ends up having a many-to-many join the Cartesian product is, that's usually an error situation. So that's not something that we ordinarily want to do. All right, but so that's with this normalization, and it's a design process. It's a bunch of steps we go through. All right. So this is from COD again. This is his what we call his normal forms. He has 5 normal forms. I think there might be. I wonder if there might be more. There might be actually be a sixth one or seventh one. All right, but usually the five here are the ones that are you go through, and really what you do is this is a design process. So you sit down, you talk to what happens is a database administrator, database designer, sits down, talks to people in business, and asks them to describe what they're trying to do, the process, the things that are involved with it, what are all what's all the information that's important. We take that information as you take that as a first cut. What we do is we make um, first cut is you make sure that all of the records are the same. All right, because you don't want to have something with a record. The first row or the first record in a database has 5 fields and the next one has 2. All right, so you have to make sure that all of the records in a particular table have the same number of fields. Um, second normal form starts dealing with the keys. Like you want to make sure that your fields, non-key fields, are a subset of the key. All right. So the only thing that should be in the key is the key, not a non-data field. Right. Third normal form is when we talk about non-key field is about fact about another non-key field. All right. So that's this stuff is really the relational rules as you look at it. Relational theory is kind of it's mathematics in its own right. So there's kind of the mathematical side of this stuff, and then there's the stuff in kind of the industry, in the real world uh, kinds of views of it. So the forms fall under more of the mathematical basis of it. Um, but fourth is record type should not contain more two or more multi-valued values about an entity. So basically, on a many to one, there should only be one. You shouldn't have a record. You shouldn't have a record have more than one fact in it, or multi-valued facts. All right. So this is really, and what happens is that most database designs usually you got to get it up to about fourth normal form. Once you get the fourth normal form, you've got a working database. Fifth normal form is deals more with the deconstruction or decomposition of data. So the idea is that, say for example, if you've got a bunch of, a particular something is made up of like a number, or like a number would be from an accounting perspective. You're on your on a worksheet, you'll have numbers that are made up of your expenses and of your revenues. All right, so you come up with a number on that. And what you can do is that number could either be the number, or you could leave the individual numbers there and add them all up and give you that number. So what happens is under fourth normal form, you could have, the number, you could have a total number, and then you could also have the individual numbers, the individual pieces of that maintained in the database. In the fifth normal form, there is no summary. It's all the detail. And what happens is this gets done. The rules around the fourth and fifth deal around with optimizations, because when you get a database of a couple million rows, and when you do a query, you have to read a couple million rows. All right. So the idea is if you can pre-summarize the stuff, in another, into another field, that's it's technically redundant, but it also speeds up what you're trying to do. Right? So these are all of the high level. These are all the code, the numbers, uh, the different steps we go through. All right? But for the most part, what you want to remember is, most working databases are either fourth or fifth normal form. Different data types, very similar to what we saw with Excel. All right, data types for each field. Though when we start off with Excel, we start off with a general data type, and then we have the option of changing it. All right. Whereas in a database, every field has to be assigned its own specific data type. So text, number types, date, time, currency, objects. You'll see, like I said, you'll see similarities between what we have in Excel and what we have in Access, because they are, of a common platform. So metadata is the description. It's the data about the data. So it's a description of of the structure of a database. So we describe, describing and identifying information resources, the author, the structural, what is the, what is each table called, what is each row called, which field called in database. All that stuff is defined up front. Right, so remember I said that begin we do a whole design process. All of the results of that design process ultimately end up as metadata. All right, and the metadata is how we use to basically to recreate. We can once we create a database with the metadata, we can take that same metadata, put it on another machine, create another database, and load data into it. All right. And it also contains information about security. So SQL, structured query language, or SQL, all three of these people, we use all three of these names. So we have SQL or SQL or structured query language. All right. What it is, it's the language to analyze and manipulate data in a relational database. All right. It's derived from relational algebra. All right. So it looks, there's pieces of it that almost match. If you look at a formula in relational algebra and look at SQL, you can see almost a side-by-side comparison. All right. A couple different subsections of this that are within SQL. Something we call the data definition language, DDL, enables us to create, how we create the structure. All right. So you create a database, and you create a table, or you alter alter a database, or alter a table, or you can drop. So what drop means you delete. When you drop a table or you drop a database, it basically you erase it. All right, so that's all part of what we call DDL. The commands are in this grouping are all DDL commands. Data manipulation language, DML. This is really the lion's share of where we most people live who are working with the database. This right here, the data definition language, is usually done by the data administrators, database administrators. Right? So normal people, regular people are not using this. Whereas on the other hand, DML, the commands do insert, update, delete, and when we say select, read data, find data, but a select, all of that stuff falls under DML, data manipulation language. And this is really represents, a lion's share, the majority of what we go against when when we're working with the database. A couple other pieces of SQL, we call transaction control language. One of the things the database management system does is it protects data. Right? It's its prime directive. And one of the ways it does that is if something, it organizes, when you're changing data, it organizes it into a block of work such that you're making changes, but nothing is locked in until the very end, and that's called a commit. With the idea being that if you blow up, if something happens before you do the commit, all those changes you applied get rolled back. All right, so you don't want to necessarily, because otherwise, the first bad transaction, the first bad thing that happens, you've blown up the database. So, and we have to at least make it more difficult to blow up the database. Right? The rollback is what we call when we end the transaction and roll back the data. That's what That's what a rollback does. And the DBMS does this stuff automatically on our behalf behind the scenes. All right. And then finally, we have what we call data control languages, which is really around how do we apply security to tables, to fields, to the database itself. So this is all through what we call DCL. So we're talking about queries. Queries are questions, formulated questions. All right. So we create a query. A query can be based on a single table, or it can be based on multiple tables. We can add fields to the query, any number of fields that they're in it. Then we execute it, which gives us a result, and then we can save it at the end. All right. So this is all, So queries are one of these things that's the essence of what we of how we interface with the database. So we go to the DMS, we develop a query, which is basically a question in a particular format, an SQL format. We give it to the DBMS. DBMS will take it, decode it, figure out what you want to do it on our behalf, and return the data to us. It returns the data, and it's something we call a return set. And we'll see this in a minute because I'm going to do some demos of Access. All right. But this is, the steps we go through when we're going to ask a question to a database. So this is this query and query design. So this is an Access thing. So actually, let's take a quick look at Access because sometimes this stuff is easier to do. All right. So I'm going to go to Access. So this is a database. This is actually we call Sam's Club, the Sam's Club database. Sam's Club database is a database from represents data that was captured in a Sam's Club store. I think it was back in the early 2000s, and was processed by captured and put together in such a fashion for academic purposes. So it was I think it was came out of the University of Wisconsin is the one responsible for this. So this is made available for us. But it's a relational database that represents a piece of Sam's Club, the Sam's Club business. All right. So we've got a members table because remember Sam's Club, you have to be a member, so you have to have a member, you have to have a card and a matching number. We have items that are in the that we have items that are in the that we maintain in inventory. So that's called that table is called item description, and it's just simply a list of all the items and a description of what they are. And then we have the store visit. So the store visit is when a customer comes in, buys a bunch of stuff. So they go in, show their card at the door, walk around the store, throwing all the stuff into a cart. Takes it for checkout. Checkout. Customer hands the card to the checkout clerk. They validate the number, and then what they'll do is they'll scan all of the items. All right. And what this is designed to do, the system that's capturing this data, what it's designed to do is it'll create a record in the store visits table, which records like the person, the date, the time, and some summary information. And then it'll also collect all of the items scanned. Right? All of the individual items that we purchased are scanned and scanned into it. So the idea is what we'll have is four pretty big tables. So if I do, let's take a look at some of these. So we'll take a look at the members table real quick. So this is the members. We have a membership number as the key, some information, zip code, the membership type, the date, the renewal date, and the join date. Right. The item scan table has a number, what they call the visit number. So this is the code that indicates, what that customer, that we used to determine what that customer did for that particular set of purchases. All right. Is that oh, sorry about that. That is actually the item scan table. So actually the store visits is what I want. So store visits represents the store, the visit. So it's we generate one record per each member visit to a store and purchasing of stuff. All right, and then we have the item scanned. There we go. So item scanned is a list of all of the items that were scanned, that was part of that sale. All right, and what we maintain is the visit number that ties these two together. All right, and then finally we have the item description. So the item description is the what the item, the number of the item, some category information, the description of these things, and the brand. All right, from the size of the tables, we've got 39, about 4,000 records in the items. The store visits, about 40,000. Items scanned, about 200,000. And then members, we have 15,000. All right, so there's a fair amount of data to work with here. So which is good because we really want to be able to demonstrate the capability of a relational database. You want to have some reasonable set of well-organized data. All right. So I'm going to do a quick query here. I'm just going to run a query. So where you create a query, you go to create query. I select a table. So what I'm going to pick is we'll pick let's do our item descriptions. I'm going to close it. And then what I have is, so this is a grid. This little gizmo right here, this grid is what we call QBE, query by example. So it was developed by IBM. I think it was developed by IBM. back in the 70s. And it was designed to be an interface that allows people a more user-friendly interface to develop SQL. It's built into Access, so we didn't have to add anything to it. And what it does is it lets us build a query. It lets us build queries, ask questions of tables. All right. So in this case, I'm going to be working with the item description table. So you put your tables up in this space up here. And then what you want to look at, what you want to see is you want to select it, a field. Actually, I'm going to take everything and just drag it down here. All right. So I'm all set up. So the way I've done is I have a table, and these are the fields I want to retrieve. And what I do is I say run the table, execute it. What it will do is it'll go out and find, you know, retrieve that data and bring it back. All right. So as you can see, we brought back all 3,945 records, each one. And you can count it, but there are 3,945. All right. So, which is, which is actually kind of useful, but let's do something actually useful, more useful with it. Right? So all this is a query I executed, which gave me the list of every record in the table, which I can do that by going directly to the item description table. Well, let's do something different. Let's go to the query. Let's change the query, and let's look for something. Let's take a piece of this. We don't want the whole thing. We want a piece of this whole set of 3945. All right. So the way you manipulate a query in Access is through what it calls the view. All right. So the view is it really just changes the user interface. All right. So what you have in a view is you can have the datasheet view, which is what you get when you execute the query. All right. Or I can get what we call the design view, is what we saw here. This is the design view, is where I set up the query. And then third, what I have is I actually have the SQL view, which is the SQL commands. So I could have sat down and have written this out. Select from item description. I could have done that, and I wouldn't gotten the same result as I did by running this. It's the same thing, just a different presentation of it. All right. So let's do something like this. Let's find a. I want to look at the description. I want to find. We'll look for everything. Um, we'll do a lookup. We'll do a like K star. So what I'm going to do is the way I would read this is all right, go to this table, bring back all these fields, and look, but only bring back the ones in which, in the primary description field, the first character of the primary description is the letter K. All right. And that's what it did. Only K. All right. Only 68 records out of what I had before, 39,000 records. Only 68 of those 39,000, or that number. Yeah, excuse me, 3,945 records. Only 68 have the letter K. All right, and this is the query I ran to do this. So it's a lot like I would liken it to. It's a lot like filtering in Excel, or actually filtering in Excel is really an adaptation of this. All right, so this is, the reason it looks familiar is because they kind of took this and they adapted it and were running it inside of Excel. Okay, so that's a basic, so quick intro to queries. Let's go back to our kind of walk through our presentation. SQL. So this is the So this is what we said. The query design allows users to select the fields and tables to be queried. Very simple. You have your tables that's in the database. Drag the tables onto the field. Select what fields you want to display. Put your criteria in. I want to find something that equals something or greater than. Do you remember all of our logical functions in Excel? These are all the logical functions from Excel. Same basic things we can do. So we can combine these things. All right. So we put our criteria that must fit. So in this case, for this particular record here, we want to get the last name, first name, and state from this table, only where the state is equal to PA. If you'll note, I have all of these fields in the table. I don't need all of them. I can just do one. Or I can do 1, 2, 3, as many as I need. I can retrieve any number of the fields that are in a table in a query. So, and then what this is called, when you get the results back, this is what is called the results set, right? Because this is derived from, it's relational algebra, so it's all set theory. So what happens is you've got the two sets you're working with, and the results set is what happens after you apply the relational algebra to those two different sets, or multiple sets. It could be two or more. Or actually, no, actually, it could just be one or more that goes into it. And whatever you get back we call it the result set. So the criteria in order to select our subset of data, filtering it, looks very familiar like our logical functions inside of Access. Wildcards. So wildcards are fun because wildcards let us, one thing to enter, looking for specific values. Wildcards give us the ability to do searches of characters in a table. Like what I demonstrated in that query was I wanted to get everything that began with the letter K. So what I did was I said something that was like K star. All right. So the way that would be interpreted is find something that looks like this K and anything after it that matches any number of characters. So that's a wild card. So you can find, as I said, as you start looking at it, very powerful because you can find almost anything, based upon the different attributes. Now you can people can get very exotic and very sophisticated with their queries and query designs and things like that. But that it does, you do get answers. And the thing is, when you're working with this stuff, when you're working with SQL, is if you design the database the right way, you're playing by COD's rules, the answer you get back will be correct. So we talked about compound criteria. When a query consists of more than one criteria. So this is the land of ands and ors. Remember that? This is what we had talked about in Excel. Remember, we would create formulas, pretty complicated looking formulas with ands and ors. In Access, or in relational databases, it's a little simpler, right? So an and is everything that's on the criteria line. So the criteria line is everything. So everything that's on the same line is an and anything that's on the line below it is an or. All right, so let's do a quick look-see here. So we got our criteria, and says both conditions must be satisfied in order for it to display. All right, so if I have a criteria, in order for this record to be displayed, the value in here and the value in here have to both match, whatever these criteria are. In an or, I have actually two sets of criteria. So each line of this, is considers a set of criteria linked by and. So it's this and this and this and this all down to the end. All right. The next line says or, and a whole nother set of criteria, and these are all ands. And down the line. So you can do sets of these. So these are the way you would read this. Everything on the line is an and. Everything on the next line, they're all linked together by ands, and each line between this one you read it as an or. So do all this, check all this, or if it doesn't match, check all this, or if it doesn't match all that, check on down the line. All right. So just some examples. So an example of an, up top would be an or condition. So in this case, we're going to find this information. So we're going to look for something that's either got a state equal to PA or something that begins with the letter B. All right. So it'll go through the first time. If it's not PA, it'll look for, whatever's, B. And it uses the like. So that's going to be a pattern. So anything that begins with the letter B. Right? Because it's on separate lines. Here, the criteria are on the same line. So in this case, what it's going to be, it has to be equal to PA and it has to begin with a B. All right, so that's the difference between. That's kind of how we represent this compound criteria on lookups. And we can do calculated formulas. A lot of the stuff we see in Excel carries over into here. All right, we have summary queries. If these look familiar, these are our statistical functions: average, count, min, max, sum. Transfer over, translate over into access in the same way as, whereas, what we're doing is we will put this into our query. We'll put that as we're putting the right criteria in. We can put that, or as we're defining the criteria, we will put that in, as opposed to putting it into embedding into a formula. All right, so it's the same as the select query. Summary queries, it's really a select query, which will then it'll select a set of data, and it will consolidate everything down. So it will add all the numbers together. So if I want to get a total line, if I have a whole bunch of data and I want to get the total, I could summarize the record, and it'll bring back a single row of data, all summarized. So the aggregation, so this is what we use. The term we use is aggregation, and we use in Access, we use something called a group by for the data, or sum for numbers. All right. So let's talk about joins. All right. So joins are, we've talked a bit about just running a query. So everything up to here has been about this idea of, executing a query against a single table. All right. So in this case, our example here, we're going against the client table. All right. But we want to do something more than that. All right. Because really, we have as I said, data is stored in multiple tables, and we want to be able to leverage the relationship to get data out. All right. So the idea is a relational database. We can connect tables together across a common field, and then access data in both of the tables for whatever we get back. This is called a join. So join is another relational database concept. This is a interjection. We join two tables together, and what we get is the result set is the intersection of those two. We can do two tables, but we can also do many tables. The criteria is they have to have a common field. Right? If you don't have a common field, you can't have a join. All right, so it's things like no common field means you're comparing apples and snowplows. All right, whereas if I get apples and pears, all right, I got a little closer. Anyway, so example. So what we're going to do is let's look at the Sam's Club database, and what we want to do is we want to get information about the store visits and the items that were purchased during that visit. All right. So what I have is I have the screenshots of these. So what I have here is this is the visit. This is what the visit number looks like. This is the structure of the visit. This is actually the structure of the item scan table. All right, so I have a visit number here. I have the item number. So these are all the fields. These are all the data types associated with the fields. All right. And if I look at the table itself, so this is the table. This is, I guess, the design view of the table. This is the data view of the table. So this is what it looks like with all the data in it. Right? That's the visit number. All right. So if I look at these two tables, so if I want to do the item scan versus the store visits, So I have a visit number in both of these tables. All right, I didn't scroll that up. So actually, I could do this we could do this in real life. And I'll take this off right now. Okay. So what I have is I visit number. So I'm doing this live here now. I have a visit number. As you can see, I have a line connecting these two. All right. And the reason I know it's connected, I can, as I'm dragging this around, the connection's there. All right. So they are joined together at the visit number. Okay. And then what I want to do is I want to find everything in this table, or actually what I want to find is from the store visits table, I want to get the register number, the membership code, and the transaction date and the transaction time. All right. And the visit number. All right. So I'm taking all of that from this table right here. And then from the item scan table, I'm going to take the visit number, and these should be the same because that's what we're joining it on. And then the item number, which has the item scanned. The item number that's in the item scanned database. All right. So if I execute this, okay, what I have is, this is the data. So all the data here, this is all drawn from the store visit table. These two are from the item scanned. And this is the result set. This is what we get back. So what it did is, the way we would read this would be, everything it matches on the visit number. So any record where these two match together. And so all these should be equal. All right, wherever those match, bring back all of the data associated with it, or the data I requested, which is in our case is just simply the item scanned, the visit number, and the item number. All right, so this is a case where I've got two tables I'm joining. All right, so let's do another table. Let's actually, well, I want to find the item description as well. So the item description is maintained in the item description table. Right, so what I want to do is I want to add this to the query. I'm going to drag it on over. Boom. And what you'll see is Access is smart enough. This is pretty smart stuff. It's smart enough to know I have a common field because they're named the same. So it actually built our query. For building our query. And then what I'm going to do is I'm just going to select, I'm just going to double click this, and I'll have the primary description. All right. So if I execute this, did the same thing, except the difference is what I did is, the primary description, ruby red grapefruit, framed art. So this is a join of three tables together. All right. And then what I can do, as we said, we kind of come through here, and I can filter this. Yeah, and everything, if we look at the design view again, this is everything that was done on 115. This is so we look as we see all the items that were sold on 115/2000. All right. So this will give us what I can do is I can come here. So I want to find everything that begins with R because I want to find ruby red. We'll do like R star. All right, we'll execute this. And what I find is everything that begins with the letter R. So it's all of our ruby red grapefruit. Anything that's reduced fat milk. So you can drill down. I can put, if I just want to see ruby, anything that begins with ruby. So I come back over here. All right, so let me go back through what I had done. So when I executed this, what I would get: fields from the store visits, fields from the item scanned, and the visit number from both tables. And this is the results of the join. And we can do another one. So this is the other one we did. This is when we wanted to add the description to the existing query. So all I wanted to do is I added the item description table to the query and joined the scanned items to the item description. And then where those matched, I would display the item. I would display the item description, product description. You see the item number, primary description. So I match these two. Across item number. And then the query does, oh, it's right here, the item number. I match the item number across the two tables. I match the visit number across the two tables. And then I have data from, 1, 2, 3 tables. All show together. So that's the join, the power of a join. So there's no limit to the number of tables probably, but it's very extraordinarily high. It's really the limiting factor is making sure you've got a relationship between all of the tables that you can leverage. It's a matter of identifying these, connecting them together. So let's take a look though at, as I'm looking at this, we'll just escape this for a sec. Let's go back to the database. All right, so this is the view. I added the, everything that begins with the letter R. And I said we have, we have in our view, we have the datasheet view, which is what we get from the results of the query. We have the design view, which is what the thing is designed to do. And then we have the SQL view. So let's look at the SQL view. So this is the commands. What Access does for us is it will, when we use the QBE, the query by example, it will also generate the SQL commands for us. All right, so we can enter the commands by hand. All right, a lot of times this is what you end up doing. Usually the SQL commands, usually not using QBE. Usually if you're a programmer putting stuff into writing things into a program, you're usually coding a select statement. Select that. So select store visits. So this has the table qualifier, the field table qualifier. So it's pretty wordy. All right, and then from store visits, inner join to the item scans on visit number equal visit number, and store visit number equal item, inner join. So this is the description of this, of how we actually are pulling this off. We're describing we have multiple joins tied together that are called out. All right, so the access makes it very simple, but this is the coding we would see. So this kind of gets more like, when we get into the land of our formulas and stuff, this is not unlike, working with SQL. But, you can create very complex SQL just the way saying we can create very complex queries. Oh, excuse me, very complex SQL the same way we can create very complex formulas. So just to wrap this up, once I get a resource, so this is the data from the store visits, data from the item scanned, data from the item description. And that is it for our summary of SQL.